high operational costs, but also incur a high cost for the large amounts of parts that they're buying and storing, and that they may not even end up using. Um, so on top of that, we have unexpected downtime costs that lead to up to $3 million in incidents, and these really do happen. So they happen at a frequency that's more than anyone would probably anticipate. So all of these things together have this ripple effect that really magnifies and becomes a really large issue. So let's talk about how spare parts are kind of a gateway to on-demand manufacturing, because that is kind of the solution here, right? Is to be able to produce parts on demand when they're needed, to solve a lot of those issues. So, though legacy parts have kind of always been viewed as not a great application to get the most out of what AM technology has to offer, in reality, there are supply chain issues, and those are results of spare parts not being available. So it's those applications which are kind of the gateway to help companies adopt, scale, or justify the use of AM, because there is an opportunity here for AM to play a very big role in solving that problem. And we know AM will continue to sort of make its way into future systems, but there will be, there's we have a very large problem to solve in the immediate future, which is decades worth of spare parts that need to be supplied. So now we can pivot to, how these on-demand manufacturing practices actually supplement existing traditional supply chains. We're not saying, hey, we're going to replace all of what we normally do with supply chains with additive manufacturing, but we are saying that AM has a role to play here in the overall supply chain. And I think it's, again, I'll keep stressing this because I think it's really important. It is a very big opportunity for our industry. So on demand, AM works alongside the regular supply chain, and it gives not only a backup plan for when it's needed, but it can also help optimize like key supply metrics. So when traditional suppliers can't deliver, you can quickly make critical parts on site utilizing on-demand AM. And we think that this hybrid approach makes our supply system actually much stronger, and it helps companies stay operational even when faced with unexpected challenges, and allows them to optimize their supply chain where they can. Okay, so now, I'd like to go into when we're going through, here's some more numbers through the implementation of, part identification on-demand manufacturing. Here are some numbers that kind of put it in perspective on how some of the benefits that we can see. So number one, more resilient and sustainable supply chains, and we kind of just talked about that, the sustaining and the supplementing of additional supply chains. We're going to see that benefit immediately. Decreasing inventories by up to 75%. Again, reducing those giant warehouses that people have full of spare parts that they might not even be able to use, and they need to be able to get those parts from those supply chain warehouses to the actual location anyway. So there's even more, an added layer of supply chain just in having those warehouses. Up to 30% lower operational costs, right? Someone needs to maintain those supply chains, someone needs to maintain those warehouses. If those aren't there or reduced, we can reduce operational costs as a whole. And then overall, reduction of 75% in lost sales from these current traditional practices. So again, just putting numbers to this on how big of a problem and how big of an opportunity we have as AM to give a solution to that problem. So we've kind of talked about what are the benefits, where can AM play a role. Now let's talk about what is part identification, and how can we utilize this to help on-demand manufacturing and to help bring more parts into the AM world. So part identification, and I love this visual we have here, but essentially what it's doing is It's determining which parts are good candidates for 3D printing or additive manufacturing. So if you look at the diagram, it's kind of like a funnel, right? We're starting with all the parts. We can then narrow it down to in a broader sense of like, these are generally suitable for AM. Narrow it further to these are technically suitable. And then we can get into analyzing things like geometry, material requirements, cost, lead time, get really more granular in order to narrow that funnel even more to get to our optimal parts. And the way we can do this is we can actually, it's a very manual and tedious process to do this without any assistance. So we can actually, leveraging AI and machine learning is going to help us, intelligently evaluate these parts and be able to do it more efficiently than we could just manually doing this with engineers without any support, which when you're doing it the traditional way, it's much more difficult to scale. So leveraging AI and machine learning is going to really help us scale AM part identification. So AM part identification, an interesting thing about it is it's not just a yes or no, yes, this part is good, no, this part is not, sort of black and white comparison. It's actually more nuanced than that. So for instance, if we start with the first kind of way that it's a little more nuanced is technical feasibility does not always equal economic viability. So a part might be 3D printable or good for AM technologically, but it's not cost effective. And we need to do things like take into account the total cost of ownership and have analyses on this to really know, is this not only technically feasible, but is it economically feasible? Another aspect where it's not black and white is that redesigns can shift that viability, right? So originally, when you go and look at a part, it may not be suited for AM manufacturing, or AM production, I should say. But when you redesign and optimize that part, it can then become very good for AM, and unlock the benefits of AM technology. So when you first look at a part, it may not be good, but then after redesigns, months later, you may pull it up after some redesigns, and it may be perfect for AM. So that can change, and which kind of brings to the next point, which is that viability changes over time. So AM, we are advancing very quickly in things like materials, technologies. Um, there's shifts in supply chain, which leads to changes in production volume. All of these things play into this change over time aspect. So to be able to have all your parts in an inventory and have an initial analysis done on them, and then be able to go back and check months later and over time, is this now viable? Is this now a good AM use case? I think is a really powerful thing to be able to do. It's very proactive, it's not reactive. And I think we, as an AM industry, need to be more proactive to some of these things like that. So I think it's really cool to be able to have this sort of dynamic. And as long as we're doing part identification in a scalable way, it's easy to adjust to these changes over time. So, bottom line, why should you care? Why should anyone in AM really care about this? I think to start, AM part identification helps you make smarter and faster decisions about what to 3D print and what to produce. So it takes kind of like the guesswork out of that equation and lets you focus on what parts are, will truly benefit from additive manufacturing. No more print the part, take a look, does it work, does it not, scrap it, redo. We'll get it right from the first time. We'll get some sort of indication of, is this going to work for AM or not? By identifying the right parts for AM, you can then speed up your production process. So instead of waiting weeks for traditional manufacturing, you're going to be able to get those critical components that you need on demand, when you need them, but also like where you need them, with having that on demand network. So again, it's really helping the supply chain aspect there and the speed and readiness of parts. And It's not, when we talk about this, it's not just improving what you already do, it's opening doors to new opportunities. So, AM part identification can help you develop uh, innovative like service offerings, right? Things that you normally wouldn't have been able to offer before, new offering, new revenue stream. So there's that aspect and new business models and setting you apart from the rest of the market. If you can do something with AM and enable a new use case that somebody else could not because they didn't identify the right parts, they didn't know that those could be produced through AM, it's going to open you up to new opportunities and set you apart from others in the market. And the fourth point here is effective, AM part identification allows you to maximize savings across the entire value chain. So not are you cutting costs on lead time, but you're making your operations more efficient and responsive, which will cut down on cost and time savings across the entire value chain. So I think these are some really four solid points on why it really matters and should matter to a lot of people in AM. So let's talk about some common challenges in the defense and energy industries. So, it, you know, in military operations, for example, a missing part isn't just an inconvenience. It can compromise mission readiness and even magnified it to national security. And if it keeps adding up to multiple instances of this. Um, so when conventional supply chains fall short, every minute of downtime it matters, especially for the military. For oil and gas, whether we're talking upstream or downstream, in equipment failures due to parts shortages don't just hit the bottom line. They also lead to production shutdowns, environmental risks, right? Especially now with the way the environment is and the sensitivity to it we all have because of the way that it's progressed. We want to make sure that we mitigate as much environmental risk as possible and the safety hazards for the people involved in the oil and gas industry. It's very dangerous field to be in, so we need to make sure that we mitigate those risks as well. So additive manufacturing is a game changer for both the sectors through rapid identifying and producing those critical parts. We're going to be able to keep military assets combat ready, keep oil and gas operations flowing smoothly, regardless of what happens with the traditional supply chain. I think COVID was a great example of this, where a lot of industries, most industries struggled with the supply chain due to an unexpected disruption. So I think we can take learnings from that and be able to apply it to industries, especially where there's mission critical parts involved, to make sure that we don't succumb to supply chain disruptions. So here are some common challenges that are faced in both energy and defense. Um, you know, the they both have these large domains. We'll start with that, I guess. They have the energy and defense sectors have a surprisingly amount of similar challenges when it comes into you know keeping their equipment running, and it starts really with these large domains. Oil and gas has upstream, midstream, and downstream. Defense has air, land, sea, space, and cyber. So both of these industries rely on this complex web of suppliers and manufacturers spread across the globe and throughout these different domains. And it can be a pretty tedious task to keep all of that going. Um, and this isn't just about off the shelf parts. This is equipment that is highly specialized and one of a kind. And that is true for both industries. The parts that you need for the military operations and for oil and gas are very, very specific, and you will not see them anywhere else. So that makes it even more difficult for them to get these parts. In both industries, downtime is not just inconvenient; it is mission critical. So every minute counts. Whether you're on a rig or you're defending the country, these are very high intensity, mission critical situations that both industries have on a day to day basis. Another similarity here is these industries keep their equipment for decades and they're using them for decades. And that often creates a scenario where they're outlasting the companies that made them. which then creates the scenario of they're unable to get the parts from those OEMs. Um, as the systems age, also maintaining and repairing them becomes a big headache because those parts are no longer available. So in energy defense, we're dealing with critical components that, you know, not only have to meet these rigorous standards and specifications, but they need to go through all of these challenges in actually procuring the parts in the first place. Um, there's also no room for error when, you know, in these two industries because of the delicate nature of what they do and the high risk environments that they're in. So I think additive manufacturing brings its own set of challenges to the table, right? We're not just printing parts, we're ensuring they perform as well or better than traditional ones. So, you know, and through that process, we need to maintain traceability, implement robust quality controls. So these are all challenges that AM is facing, but really is magnified in energy and defense because of all the things we just talked about. So I think, you know, we're operating in a landscape where these comprehensive standards and qualifications and certifications for 3D printed parts are still evolving, um, which makes compliance a complex but crucial task. And again, adds to these challenges. All of these challenges just keep adding up for energy and defense, but they do have all of these in common. And I think we can solve a lot of those through AM and through good part identification. So let's get into the weeds a little bit about we'll give two examples, one from defense, one from energy, and how they differ and what those experiences were like for them. Because they kind of took two different paths, which we'll outline here. Um, when we work with customers and solving all of the challenges we just talked about through part identification, using on-demand manufacturing, there's two routes that they sort of go. We have customers scaling their parts um, in these two different ways. We can do mass sort of inventory analysis at scale, and we can also do a case by case basis where it's imperative to empowering an organization. So one is mass inventory analysis. The other is, hey, I have this part. We really need to be able to get this part or improve this part. Is AM good for this? Two different scenarios here. So we'll start with the scenario of a large inventory management at scale. So that's the United States Marines with us 3YOURMIND. The Marines, they are creating a digital library of their parts, but they were kind of inundated with the scattered complex data. There was a lot. So enter Operation Trailblazer. This was our project to boost the Marines' additive manufacturing game with us helping them and leading the charge. What the mission was to find 3D printable parts faster and better than traditional methods of part identification. So utilizing 3YOURMIND and being able to use the AI and machine learning involved and be able to be a consultative voice for the Marines and go through this with them, we were able to tackle a massive challenge. We analyzed 10,000 parts from all sorts of from everything from technological drawings to diagrams to documents to files. 3YOURMIND can, and a lot of other, can take in a lot of different types of files and be able to work with a lot of different types of data, which is necessary when, they may a piece of equipment from 50 years ago doesn't have a CAD file for a part necessarily, but it will have a diagram or something like that. So we can use that data. What was the result? We found over 300 parts that were identified as prime candidates for 3D printing based on both cost and technical factors. So it's not just about saving money, it's also about making them more self-sufficient and mission ready as well. Now in year 2, we're going to take those 3D printable parts and we're going to test them in Marine operations and prove their worth in the field, which I think is a great use case for AM, a great story for AM. And it all started with, hey, here's 10,000 possible parts. How can we get down to the 300 that are really viable for AM? which is a pretty massive challenge, but it was very fruitful. So again, here's just a quick recap. 3% of those parts were, demonstrated AM potential, and 57% of high priority parts were suitable for metal AM, and 30 parts were listed as high priority. So again, it's just to put that in the grand scheme of things, how much that whittled down to find those use cases is a very demanding task to do manually. So utilizing tools like 3YOURMIND is really helpful in lowering that threshold of work that needs to be done in order to get the part identification. And when we can lower that threshold, get more AM part identification, everyone in AM wins. We get more AM use cases, more AM parts. So it's really, I think, critical for our industry to start doing this more often. Now, the other side of the coin here is we had an upstream oil field service company that had one specific part that they were really having trouble with. So an oil field service company, they were hitting a wall trying to get this crucial pipe connecting tool called a stabbing guide. Their usual suppliers were either gone, too slow, and were leaving them in this tight spot with really costly and disruptive delays. So they turned to 3YOURMIND and to part identification to see, can Additive solve this problem for us? The software then, we analyzed two big 20-inch parts and said, yes, we can actually make these, and it is a good use case using wire arc AM. So not only did the part identification and the software suggest how to make it, but it also was accurate on cost estimates and matched the real vendor quotes. So when put to the test, because again, we really need to make sure we test these parts and that they produce results that are as good or better than the traditionally made parts, the 3D printed parts passed with flying colors, and they proved that the analysis during the part identification process was spot on. So the bottom line here is 3D printed parts. By 3D printing these parts, we delivered them faster than traditional methods, and we kept operations flowing more smoothly, and made it possible for this upstream oil field service to be able to acquire these parts when they were struggling to do so. So AM kind of came to the rescue and was able to provide this. So those are kind of two different avenues of part identification, and two examples of how, when we really needed mission critical parts, whether that's in the Marines, whether that's in an oil and gas company, through good part identification practices, either a large inventory, narrowing down of a large inventory, or through a single use case, can really enable AM to save the day and provide a good use case. So just some final thoughts when we're talking about all of this. We 3YOURMIND, we are the software to go to for on-demand manufacturing, and it is something that is very important in this industry. Remember, the goal isn't just about adopting new technology, it's solving real business challenges. Part identification software helps you discover where AM adds value for your organization while reducing the risk and all of that overhead work that can come along with it. Again, with the Marines, 10,000 parts, that seems really demanding and like a really hard lift to do. But through good part identification practices and through tools like our 3YOURMIND software, we can lower that threshold and get people really working with AM more, and leads to more internal AM adoption. I think another good takeaway is to be proactive with your IP through part analysis. Right now, the AM industry is very reactive. I think we all know that, and I think we all need to change to be more proactive in our approach to that. So I think being proactive, identifying your parts, having a good inventory of them is really a good way to start being more proactive on some of these issues that arise. And all of this is only possible through a standardized, repeatable process for part selection to help you realize those good AM use cases. So it all comes really back to that, and software like ours helps with that standardized, repeatable process. And we, as 3YOURMIND, also, and there are services like Additive Minds with EOS, where we will help guide you. We're not just going to, leave you with some software and hey, figure it out. We are there to be a guide on how to set these standardized, repeatable processes for part selection so that you do find those good AM use cases and increase AM adoption. And with that, I will conclude. And are there any questions that anyone has?
All right, great presentation. Thank you, Tyler. Yeah, we'll now head into the Q&A session. So if you haven't done so yet, please get your questions into the chat. Alternatively, if anybody's feeling brave and you want to come off mute and ask your question directly, you could do so also. All right, let's see. Yeah, go right ahead. All right, we got one hand up. They able to come off mute? All right. Yeah, Madhu, you can come off mute and ask your question.
Hi, good morning and good afternoon. I have a question here specifically for the defense sector. The defense sector has to have a lot of controls on the security side, and regarding server locations or maybe some of the restrictions from different organizations or countries. So how this server or your library will restrict or follow them, compliance to them?
Yeah, so if I get your question right, you're asking how do we tailor to all of these strict security requirements of industries like defense?
Yes, exactly.
Yes, so we have a few ways of doing that. We can do on-premise installations of the software, so it stays within their confines of their network, so it can't access the internet. We can do GovCloud, ITAR. We can do all of that in order to meet those requirements. We also have a bunch of security protocols that we go through to ensure that we are adhering to all of the requirements that they have as well. So we'll go through questionnaires with them. We work with their IT teams to ensure that the software is fully secure, because again, all of their IP is in there. So it's very, very important that it's as secure as possible. So there are different ways, including the ones I mentioned, that we enable that.
Okay, thank you.
All right, thanks for that. Any other?
That's something we get that a lot because everyone's parts are in there, so it's a little, it can be, it's really very important for us to make sure that it is as tied up as possible.
All right, thank you for that question and answer. Any other questions coming in? All right, like I said, if you want to just come off mute and ask your question, you can do so. All right, I don't see any other questions coming in. If you do have questions or you think of anything, you can go ahead and add it in the chat, and we can follow up with Tyler afterwards. So yeah, thanks, Tyler. I think that's going to wrap up today's TRX webinar series. I would like to thank everyone once again. If you do have further questions, you can reach out directly to Tyler. His information is there on the screen.
We're also at Rapid right now. I don't know if anyone else is. I'm at Rapid, and our CCO is here as well. So if you want to come see us, you want to chat with us, we're happy to do so. We'll be walking around. Our emails are right here. Just shoot me an email, and would love to meet with whoever wants to chat.
All right, great. Thank you. Thank you very much. All right. So yeah, and as a reminder, if you think you or your organization would be interested in sharing on the TRX webinar series, You can fill out the form that is in the chat, or you can reach out to Zane Ross directly at zane.ross@ncdmm.org. Thanks, everyone, and have a great afternoon.
Thanks, everybody.
Bye, Tyler.
Thanks, everybody.
Thank you. Thank you.